So let's start with our first presentation for today. Later on at 3 o'clock German time, we will have the same presentation once again. So if you want to invite a friend or see the presentation again, you are welcome to see us at 3 o'clock again. I will work together with my colleague Jochen Sagolla. He is one of our technical advisors, and he will run the software later on and present a live case presentation to scan and to modulate on an implant abutment. So we will try to show you step by step how everything works. We are in the complete Tizian workflow, and actually our new module for the Tizian Creative software is called Abutment Designer. This is a tool where, depending on your milling machine, you are able to mill your own custom-made abutments from zirconium on top of an implant. But depending on your milling facilities, you may need a little help from a titanium platform. We call it interface or adhesive bases, and these platforms are available from different companies. For example, from NT Trading or ZFX or Medentica, or the new interface for Impla is of course available from Schütz Dental. So how does it work? Usually you prepare your model as usual. You prepare it with a gingiva mask, and you need a specific part which is called scan abutment. You see that here in the picture. That is later on the scanned picture from the scan abutment, and Jochen will show you exactly how that works. So you need a specific scan abutment according to the implant which the doctor has placed. This is very important to know. And to prepare your later on construction, you need a second part which is called scan platform, interface platform or titanium platform. This is also a special part which has to be matched to the implant system which your doctor may use. So please make sure what kind of implants your doctor may use and if they are available already in the software. I will show you later on which systems are already integrated. So basically this is what you can do or what you do. Jochen will show you more in the details what the software is about. Two little important differences. We will later on construct a zirconium abutment, full zirconium abutment on top of a titanium plate, or maybe direct milled. And the difference is according to your milling machine and not according to the software. From our experience, we have the possibility to do two different types of abutments. One type is the so-called custom-made abutment. This is a two-part abutment. One is made from the titanium plate, and on top there is the zirconium body. And this is what you see here in the picture. This part here, which I mark with my marker, this part is the zirconium body, and this is possible to mill with your milling machine with 4 axes. And later on you have a part which fits to the implant, which is an adapter which has to be glued adhesively with composite glue, for example Panavia or Relay X from 3M, and then you can fix it into the mouth of the patient, screw retained or with a cemented bridge. And that is the big difference. With the 4-axis milling machine, you cannot do screw retained bridges from occlusal. we have to find a secondary coping, like this here, what you see. And the big difference, if you have a 5-axis milling machine, you can do a complete zirconium abutment with a screw channel here from the top, because the 5-axis milling machine can do the different angulations in the screw camera. I hope that is a little bit clearer for you later on in the live demonstration, but please take an eye on the important part of 5-axis or 4-axis milling machine. But software-wise, it is the same, so all the steps on the software which we will show you are the same, and later on you have to decide which milling strategy you can perform. Okay, and I want to mention another model which is released already, which is called Bar Designer, Bar Construction Module. This is what you can do with the bar construction model. Just to show you a little preview for the next webinar, this bar construction model is based on the abutment designer, because most of the bars are fixed on implants, of course. So important for you to know, you need that abutment designer first. So which implants can be done with the abutment designer? This is actually the list from our CAD-CAM information. You see here, CAMLog, we have 3 types of implants, the Provital, and anti-trading provides us with all these, for example, implants, Dentsply, Astratec, Straumann, no Biocar Brennemark system, the Replace Select, and so on. And the latest innovation is also the parts for our own system, the implants with the hexagonal connection. So this list is available in our CAD-CAM information, so you can have that as a PDF file if you may need that later on, let me know. Okay, software requirements. Usually we need the basis software of TCM Creative RT in the version 3.9 or higher. Its software runs on all our PC systems, so 32-bit system, 64-bit system, and also the new model, the workstation. Of course, the performance is better the more computer power you have, but there is no really a limitation. And of course you can use all our scanner types which we provide, scanner 101 or the new type 102 are perfectly able to work with the abutment designer. And as I said, the only tools you need are the titanium base plates, connection screw, of course, and the scanner button. Here are some contact addresses. For example, anti-trading is reachable with this number. Okay, I will not bother you with more details and will give the moderation over to my colleague Jochen Zagolla. We will just switch our screens, and now you will see his screen and also his video camera. The video camera is already adjusted to the scanner, and we will show you what all the steps are about. So, yes.
Okay, hi everybody.
Moment, sehe ich schwarz. Das war mal ganz kurz da, aber
Yeah, okay. So here you see the gingiva mask. It's scanned already. Then you can go on, click on continue, and then we will scan the model, the upper jaw. Then you put out the gingiva mask and have only the model. Then I guess pre-scan, only the 2D scan. And then here please set the marks from different areas which should be scanned more clearly in this area. Then I go on, and then you can see here the different angles in the scanner and the scanning images. And here's the best from each different angle the model will be. Last scan from this area. And then we can continue to go on with the abutment scan. So then we have to screw the different scanner buttons into the model. So and the best position is with the flat side to the outside, but we will see it in the scanning software a bit better. Set the areas. So in this area, I set the mark here. Is getting more complete in this area. And then we have to match the data. And after that, we can take a look if everything is scanned correctly, and then we can cut the model and delete unnecessary parts of the model. So now here in this process, the whole single scan is matched together to one model, to one data file. Now it's scanning it's matching the scanner buttons. And the last step, we have to match the gingiva. And here we can cut off all the parts we do not need. For example, here, everything outside the gingiva mask. And these parts here. Then save. And now we go to the upper drawer. Here we do not need this complete part here, so we can cut off two. And here in this part we need only the scan bodies. And you can see the flat part of the scan body. So this part here is a bone, and here is the flat part. And to get this part scanned correctly, the bad thing is to have it here to the outside. Okay, then save. And here, to finalize the project, click on this button, and then we go on in the CAD software. You can see the model. Here is
our database from the implant. Here are the different types. Camlock, for example, the complete Medentica, anti-trading, and
here is our system, Schütz Dental, and here are the 3 different sizes. At first we need the implant for tooth 1.6. Here it's the brightest one, 5.6. Then click one time into this area. Here you can see the scan body. The green one is the scan, and this one is ASTL file out of the database. Then here we say test fit. Then it fits correctly on the scan.
the implant for tooth 1.4. Here it's the 3.3. Then test fit and go on. Here you set the against profile on the margin 1.6, set 4 marks, and then there is a line familiar with the preparation line, and you can correct it or change it. Then we go on to the next tooth, it's 1.4, here you set 4 marks. And here it's possible to correct it. The key out of the library. Here you can choose the Schütz line. They have a ceramic shader and a natural view on the teeth. And bring the teeth into position. You can scale it or rotate them. And when they're in the right position, you can go on. And you can generate abutment buttons. So when you go onto this part, you can freeform them. Or when you click here onto this color and it turns green, you can go through the gingiva, for example, or you can choose it in the height. When you click on it and it's this color again, it's adapted to the gingiva. And you can change here the form, for example, more bright or a bit dim, and here you can choose the top and the bottom side.
Ist ein bisschen langsamer, weil das durch die Übertragung Zeitverlust hat.
And this step is for both the same, but you can choose them individually when you want to. Okay, then the next step is freeforming. You can choose single parts of the tooth and freeform them, or the half of the tooth, or the complete tooth. Or you can freeform it with the wax knife, add material or smooth this area a bit. And here you can choose different forms. So it's round, it's default. A knife, it's like a spike and cylindrical form. And here on the knife, you can go on with these parts and freeform the whole tool. So the context we can adapt it to the gingiva. And here with one click you can adapt the whole context to the gingiva or let it space or here for example. Now it's 1.56 millimeters free here in this area. And here you can choose the insertion from the screw channel. You can see the decrease. And this is the designing of the abutment, make it a bit brighter. A bit smaller or higher. Or change here these areas, the different rings. And here in this step you can design the bottoms again. Now here you can freeform it, or maybe smooth it a bit, or put material on it. And at this step you can say, okay, please mill this part first, and you can go on when it's in zirconia and mill it, and after that you can scan it again, or you can go on with the designing and you can design everything in one step. Then here you can set the border and the cement thickness and the start, for example, or the borderline. Area here a bit brighter and more stable, or a bit smaller. Or put more cement gap on the stump. This changes here on the yellow parts. And the tooth is adapted to the stump. Then you can shrink the bone bridge, or you can exclude selected parts. For example, the lingual, and here it's select complete round. So these parts are not shrinking, or you say only the lingual part. Over here. Or you can freeform this area And the whole part which is marked blue, it's not shrinking, so you can mark these whole areas here. And these parts are not shrinking, so you have this in full zirconia and more stable. Okay, then we shrinking the whole tooth with 0.8. Then apply. Here you see this the shrinking process.
Das heißt, wir haben jetzt 0,8 mm Platz für Keramik. Könntest du mal sagen?
Oh, and this area here you see the complete tooth, and when we select the atomic shapes, here you see the construction. So at this area here is 0.8 millimeter space for the ceramic. So everything which is shown yellow here, you have to complete with ceramic. And this part here is full zirconia. Then here I click next, it's freeforming again. We want to change the position of the tooth, we can do it in this step. Or go on with the freeforming again and smooth this area a bit. Here are the connectors. The standard form is round, but you can change it into this shape, or like a drop or a tree angle. Or you can freeform this form when you change here into free. And then you can set here different rings and can freeform the complete connector. And here you have an overview how much square millimeters the strength of the connector is. And you can change the complete position of the connector, or can select different points and can set the connector onto the middle of the point, or set it back between the teeth, or take the complete connector and set it here in the middle of the construction. Okay, when you go on the designing of the screw channel, you can see here. In this moment it's connected to the atomic shape. You can see here. But you can say connect the screw hole onto the framework. Then here it's adapted to the framework, or you can freeform it and change it individually. Or you can change the complete height here.
Bisschen langsamer. Das baut sich hier extrem, wird bei mir extrem langsam auf. Es dauert wirklich mehrere Sekunden, bis ich.
So here you can change the height. Or here, single heights. Okay, then complete construction is merged together. And here is the complete framework. So at the tooth 1.6 you have the screw channel going through the complete construction. And here is the space for the platform. So this is screw retained and this one is a custom abutment. So you have the construction, the framework here is closed. And you have the single abutment part. And here's the space for the titanium base. And here you can see it fits directly into the construction. So now in the end, when there is something which you want to correct, you can go back to every single step, or you can freeform the complete construction. For example, smooth here the construction a bit, or change the position. Freeform this area. And when you click here on OK, the complete change is getting into the new framework. And here is the new construction with the changes. Or otherwise you delete the complete parts. And now you can go back to, for example, the crown bottoms, freeform the single tools, or change the connectors, for example. And every step we did in the construction we can change here. Here, for example, the connectors. Freeform it again. And then when the construction is okay, you can save the complete restoration and then you have the changed framework. So the next part, which is new in the software, is the tooth library. Here we scan the case. It's this situation for front tooth. And here we set the one mark on the preparation line, and here the preparation line is set, but you can correct it here. Then we go on to the next two. Set one point here. And here you have the preparation line, you can correct it. Here are the undercuts. These areas are blocking out automatically, but you can change the insertion from the single tool when you want to. Then you can set the current view as a new insertion axis. For example here. So here are less undercuts and here are now more undercuts. Then here the same. You can set the crown bottoms or change the cement thickness. You can see this part here is getting thicker or thinner. Or you change the start 0.6 or 0.76 for example. Here this complete area is your fitting area. And everything which is marked yellow is the cement gap. And here are the tools out of the standard library. When you click on the background, you can say load custom tools models. And here, this is the standard generic, where you have here different forms. And here's the new library, it's called ZRS. And here are a lot of tools for the front teeth. For example, I take this one, and you see it's a bit smoother and younger teeth. Or for example, this one, a bit older, and here's some marks. So for example, we change these tools from the standard library into these. Here you click OK, and then we load the new teeth. And change the position, and the handling is the same like the generic library, but here you have a lot of new teeth you can choose. Here you have the other form. And here you can scale it. And change the complete position. Next step is fitting directly into the stumps, and here is the new form. For the Schütz shader, it's ceramic. And in the freeform model here you can change the form individually. So here's the same shrinking. You can exclude some parts and make a lingual band, for example. And all other parts are shrinked, except these areas here. Then freeforming again, and the last step is the complete framework. Or here in the last step you can say connect it to the mesial neighbor, or to the distal neighbor, and can make with one click a complete bridge out of these single tools. Okay.
Sagen wir nochmal das Resultat, so ungefähr ist das überhaupt.
Kann man was jetzt sagen?
Kamera muss an sein, ja? Also selbst hier ein kleines Bild.
Okay, und hier ist.
Ja, warte mal. Steht auch ein Standbild, glaube ich, nur.
Yes. Okay. So here you see the model again with the gingiva mask. And here are the fitting titanium base. And here you see it's fitting directly into the model. And then you can put, for example, a single tooth on it. You can see here with the screw channel and the occlusion. Or with the complete bridge construction with a screw channel for the complete construction on the model. So you can see here, complete screw retained bridge with the screw channels on the top. And it's fitting onto the titanium base here.
Übertragt irgendwie nicht. Tun Sie nochmal die Hand dazwischen?
Ja.
Doch, jetzt.
Ja, okay.
So.
So here you see the complete model with a screw channel on the top.
Nö, das schiebt immer automatisch. Ja, das ist dann nur bei mir auf dem Bildschirm so. Komisch. So, jetzt müssen wir uns wieder sehen.
Also mal rausziehen.
So, wie geht's? Genau, steigt halt teilweise aus. Ja, machen wir.
Ja, okay. So here's the model again, with the screw channel on the top.
Ja, jetzt geht's.
And here you see the titanium base. The base is not screwed tight at the moment, so there's a small gap. And screw it here, there's no. So this is a complete screw retained bridge, and we have some single stumps, some custom abutment, custom. So we put the gingival mask on the model. So you can see here. And then custom abutments. Fitting here directly into the gingiva. Here's the the other custom abutment. And this, for example, you can do the framework in one step and mill it out, or you can individualize and polish these circle parts and scan it again and go on in the same way you scan a stamp. So then you can do the construction onto the custom abutments like a bridge.
Oh, das wäre ganz interessant.
Ja, das ist doch cool, oder?
Seine Sicherheit.
Okay, so this is the result. So are there any questions to these two new features of the software?
Nicht. Okay, dann nehme ich mal wieder rüber, ne? Okay, then thank you for your participation and your kind interest in our little presentation. I hope you could follow it. We have recorded the whole session, so video will be available as soon as possible.